Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 asks, how many moles of N2 gas occupies 5.2 liters at negative 23 degrees Celsius and 0.5 atm? Okay, so to answer this question, we are going to assume that the diatomic nitrogen gas acts as an ideal gas. So the reason we want to assume that the N2 gas acts as an ideal gas is so that we can use the following equation where PV is equal to nRT. So the P stands for pressure. And in our case, the pressure was given in the question, so it was 0.5 atm. The volume is V. And they gave it to us, it was 5.20 liters. And we're trying to find number of moles, so we're going to leave that. But the R is known as the ideal gas constant. So depending on the units, R can have different values. But for this question, we're going to use the value 0.0821. And the reason why is because its units are in liters times atm divided by mole times Kelvin. So since our volume is in liters and our pressure is in atm, then we can use this ideal constant. And now T is temperature. And they gave it to us in the question as negative 23 degrees Celsius. But we need to convert this to Kelvin in order to use our ideal gas constant. So to convert to Kelvin, we just need to add 273 and you end up getting 250 Kelvin. Okay, so now let's try to sub in all our values and rearrange this equation so that we solve for the number of moles. So if we rearrange this equation, we get number of moles is equal to PV over RT. The P was pressure. V was volume. R and finally temperature. Okay, so now if we want to cancel out all our units, you'll see that our ATM will cancel out, and our liters, and our Kelvin, and now our moles will go from the denominator to the numerator. Well, it'll be our final units, and you get number of moles equal to 0.127 moles. Okay, so let's see what the junior tutor said. They summarized all the different variables in the ideal gas equation, rearranged it, plugged in all of the values, and also got 0.127 moles of nitrogen gas. Okay, so this solution is correct.